In this video, I'm going to show you my demonstration of Project 2 Serial Transmit of Temperature. My name is Addison Sears-Collins, and this project was done for software development for real-time systems at Johns Hopkins University in the spring of 2019. Course code EN.605.715.81.SP19. So, right now you are looking at the Arduino sketch. I'm going to begin this presentation by going through the requirements. I'm going to then show the code and how I met those requirements. Then we're going to take a look at the hardware setup, and then we are going to actually run the software program by recording the temperature at room temperature. Then we're going to record the temperature inside the refrigerator, and then I'm going to record the temperature again at room temperature. So without further ado, let's get started. So for this project, we are required to develop an application which executes on an Arduino and transmits the time and temperature at a periodic rate of around 10 seconds across a serial bus to our host. In this case, I use the USB. And so now let's go through the requirements. The system must satisfy the following requirements. System must execute on an Arduino. The Arduino version I used right here is version 1.8.8. A temperature sensor connected to an Arduino must be calibrated. I performed the calibration, and the calibration methodology is contained inside the project document. The main program must use a round robin with interrupts design. So you're looking at the code right here. You can see I use interrupts in here, attach interrupt. This is a method provided by Arduino, which enables us to do interrupts. And then I also had to include a library called the timer1.h library, which handles the time-based interrupts. And the actual code for the interrupt service routine is right here. It's void ISR, stands for interrupt service routine, _read_temperature. And all this function really does is an interrupt service routine that reads the voltage and converts it into degrees Fahrenheit. So very simple, just 2 lines of code, that's it. Interrupts it periodically and reads the temperature. So that's one of the requirements there. And so let's go to the next requirement. The temperature must begin recording after the temperature is stabilized at room temperature. So how I met that requirement, you can see here in our main function. This line right here, where we go void loop, and then here it's wait 100 seconds for temperature to stabilize. Temperature is being read in the background via the interrupts, the timer interrupts. So we have a delay right here for 100 seconds, which you can see right here. 100,000 milliseconds, which is 100 seconds. And all this does is we only going to start really displaying the time and temperature to the screen after 100 seconds have elapsed. We need enough time for the temperature to bounce up and down and, to find an appropriate value, stabilized value. So to our next requirement, the temperature must be recorded at a periodic rate of around 10 seconds at room temperature. So here we do our recording. I just showed you that previously. We have our interrupt. I set a timer length for the interrupt of 10 seconds, and this is 10 million microseconds right here. So timer1.initialize, and this sets the timer to go off every 10 seconds to trigger this interrupt right here, which reads the temperature. So next requirement. The temperature must be recorded for 5 minutes at a periodic rate of around 10 seconds inside a refrigerator. I'm going to show you that in a second here. The temperature must be recorded for 5 minutes at a periodic rate of 10 seconds at room temperature. I'm going to show you that as well when I do my demonstration at the end of this video. Next requirement, the time and temperature must be transmitted across a serial bus, such as USB, to my host. So here you can see the code where we have serial.begin 9600. This just opens the serial port, sets the data transmission rate, the baud rate to 9600 bits per second. And here, let's go down here, we have our main program here where we display the time and temperature, and all of this code where we do the displaying happens in this function right here, where we capture the time, convert to seconds, display the time, display the temperature, all to the serial monitor. And that's what happens in this function. Next requirement, the comma-separated value file. Okay, so time and temperature data must be exported as a comma-separated value file. So I'm going to do that at the end. I did that at the end. Actually, after the end of this video, I copied the data, exported it into a comma-separated value file, which I then inserted into Excel, and I used that particular data to graph the temperature versus time. So without further ado, this is the code here. I'll just briefly walk through it. You saw how I met the requirements, but now that we've seen that, let's just go through from the top really quickly again. Here we have our library, the timer1 library. This handles our timer-based interrupts. Down here we do our declarations for our pins, our flag used to stop the program, which is a sentinel. In this case, I use the exclamation point to enter that into the serial monitor. I'm ready to stop recording. We have declare our time variable as well as our Fahrenheit variable, which is used for capturing the time and temperature. Here's our setup. Nice friendly welcome message, which happens right in here. Have our interrupts right here, initializing. And then we get to our main function. This is where the big meat of the program happens. I tried to keep this very clean. And this just says, well, not done. Keep showing the temperature in the program if the sentinel is entered. And then every 10 seconds, make sure you display the time and temperature to the serial monitor. And then once that sentinel is entered, let's say I enter an exclamation point after everything's done, we pop out of this while loop and we go down to this while true loop, which does nothing. It just sort of is in an idle state. Here are helper functions down here. We have our interrupt service routine. All that does is just read the temperature. All of these equations right here that do the conversion from voltage, which is read by the temp 36 sensor, to Fahrenheit. Those are obtained from the data sheet from the manufacturer of the actual component. And then here at the end, we have our final two functions, which is the display time and temperature routine right here, which just prints out to the serial monitor. And then finally our end program, which is responsible for keep checking for that exclamation point. When you see that, terminate the program, pop out to that infinite while loop. So that is the software. Now we're going to head over to the lab bench and we're going to take a look at the hardware setup.
Okay, so here is the hardware setup for my temperature sensor transmitter. In the middle here, you can see that I have several wires. We have this red wire on the far left is connected to the 5-volt pin. Then I have this blue wire, which is connected to ground, and this green wire over here is connected to the analog 0 pin. And all of these wires are connected over here. Oh, here's the case for the temp 36 sensor. All of these wires are connected to the breadboard, which you can see here. So the red power is connected to the positive rail right here. The blue wire, which was connected to ground on the Arduino board, is connected to the negative rail here. And then we have this orange wire over here, if you can see, is connected from the ground, this minus rail, over to the left, far left of the temperature sensor over here. And then this green wire right here is what provides the temperature sensor power. So it's connected from the positive rail of the breadboard to the far right of these three legs, the far right of the TMP36 sensor. And then the middle one, this green one, this one right here, is connected to the middle leg of the temperature sensor. And this green one, as I said, connects all the way over here to the analog. So this is what's actually reading the temperature right here. Okay, so that's the hardware setup. Now let's go over to the kitchen so we can go ahead and run the actual program. You can see I'm getting ready to record right now, and have our serial monitor open. It's kind of blurred. It's kind of tough to see right now. Bring it into focus. Program is now running. It is waiting about 100 seconds before it's going to spit out the first time and temperature data field. And this is just letting the temperature stabilize. And we're at room temperature. I'm inside the kitchen now. You can see. And there we go. You can see the first two temperatures that have spit out, 73.1 degrees Fahrenheit and 70.1 degrees Fahrenheit. Now it's going to go every 10 seconds, and once we hit the 400 second mark, I'm going to put the Arduino and the breadboard. I'm going to put this inside the fridge. This is our temperature sensor, so that we can record for 5 minutes inside the refrigerator. You can still, we are at the 300 second mark, and we're still spitting out the temperatures every 10 seconds. Okay, so now we're at 380 seconds, 390 seconds, about to hit the 400 second mark. So I'm going to put the breadboard in the refrigerator. Let's open this here. And carefully, I'm going to put the breadboard in the refrigerator. Very neatly here. Okay, you can see it in there at the laptop. And I'm going to close this ever so easily. And we are now going to record the temperature here for 5 minutes. You can see the temperature has just gone down. It was at 70 degrees Fahrenheit before I put it in the refrigerator. Now it went from 66 now to 63 degrees Fahrenheit, and it should continue dropping as the temperature inside the refrigerator gets colder. Okay, our temperature sensor has been inside the refrigerator for almost 3 minutes now. You can see the temperature has dropped from about 70 degrees before I put it in the refrigerator when it was at room temperature, and now we're getting readings down near 57 degrees Fahrenheit. So now 55 degrees Fahrenheit, so almost a 15 degree Fahrenheit temperature drop after we put it in the refrigerator. We're going to keep this, the breadboard, inside the refrigerator right here for another 100 seconds or so. Then I'm going to take it out and put it at room temperature right here on the counter. We're going to let that sit for 5 minutes. Again, it's taking readings every 10 seconds. Okay. So now you can see we are just about at the 5 minute mark. So I am going to open the refrigerator now. I'm going to ever so carefully take the breadboard out of here, the temperature sensor, and I'm going to place it back at room temperature. Very carefully here so nothing falls. Set this down. And I'm going to close the refrigerator. And now I am going to take the temperature for 5 minutes at intervals of 10 seconds while it is currently at room temperature. And let's see if we can focus in on here on our screen. You see that the lowest temperature it looked like we got was at almost at the 5 minute mark in the refrigerator. We got down to 52.10 degrees, and now we are increasing now that the temperature sensor, the TMP 36 sensor breadboard, is now at room temperature. So now we're popping up again back up to the mid 60s from the 50s where we were at previously. We're going to leave this here for 5 minutes, let it sit, continue to take temperatures, and then we are going to stop recording. Okay, so there we are. We have just hit the 1,000-second mark, which is 5 minutes at room temperature, and you can see that we have jumped up. We're back up into the high 60s Fahrenheit. Hasn't quite got back up to the 70s. And now I'm going to go up to the top. I'm going to enter in the exclamation point, which is the sentinel in the program. I'm going to go over to the right, and I will click send. Send that to the output buffer, and here we get this message: finish recording temperature, goodbye. So that is it. We have recorded our temperatures, 5 minutes at room temperature. Then we put it in the refrigerator for 5 minutes, and then we record it again for 5 minutes at room temperature. Now what I'm going to do, I'm going to take all of my time and temperatures, and I'm going to export those into a CSV file. I will then graph the temperature versus time, and that's what I will use to for the final submission. So thanks a lot.